All right, and so now for section 6.4, we're going to continue with vectors, and we're just going to talk about another operation with vectors, and it is called the dot product. All right, so if we have vectors u as components u1 and u2, and then vector v as v1 and v2, yeah, then the dot product, which we denote with just a dark circle, is all it is. So it's a little bit bigger circle than what you would use for like multiplication, is the component u1 times v1 plus the component u2 times v2. So that is called the dot product. So let's find u dot v, so it's just u dot v, when u is 9, 1, and then v is negative 7, 3. Okay. So then u dot v is equal to 9 times negative 7 plus 1 times 3, which is negative 63 plus 3, which is negative 60. And so notice a dot product here gives us a single value. Okay, now it doesn't result in a vector the way vector addition and vector multiplication did. All right. There will be examples where you will have to do more than one operation, and then you may get a resulting vector. Okay, but here we are just left with a scalar value. All right, so scalar just means an individual vector. Let's look at another one here, and this is a kind of interesting one because example 2. We're going to find u dot v again. All right, but u is equal to I minus 6j, and then v is equal to negative 8i. And what usually happens when you denote this, you'll use like an I hat and then like a j hat, and so v is negative I plus j. Okay, and in vectors, we don't use x, y's, and z's, or x's and y's to denote. Instead, I represents my x direction and j represents my y direction. And then normally it's I, j, and k if you're in 3 dimensions, where k would represent your z direction. So how I need to look at this is this vector u is really just 1, negative 6 in its component form. Okay, so it's just a different notation, but it means the same thing. Okay, now I find u dot v. So I do 1 times negative 8 plus negative 6 times 1. I get negative 8 minus 6, which is negative 14. Okay. So again, I get a scalar value. All right. And just to do one more example here with this, I'm going to say u is equal to 3, 3. And I'm going to find u dot u. Okay. So actually, go ahead and pause the video because I want you to try this on your own. So pause the video, take a minute, and try this one out. All right, so assuming you pause the video, so I'm going to do u dot u, so I'm just going to dot u with itself. So I do 3 times 3 plus 3 times 3, and that is 9 plus 9, which is 18. Okay, and again, 18 is called a scalar here. If we get a vector result, then 18 would be a or then it would be a vector. And when you get a vector is when you do things like addition with the dot product. It's kind of like orders of operations, etc. Okay. So if you have any questions, please feel free to email me. This does conclude section 6.4 and actually concludes chapter 6. So if you have any questions, email me, and have a great rest of your day.